All right, what's up, guys? In this video today, I'm going to pick up with some calculus here. We're going to be talking about improper integrals. I'm going to show you guys how to evaluate an improper integral. So I've recently gotten back into the, creating the math videos, the math content. Again, primarily if you want to see any of my mathematics videos, it's probably best to follow me on Instagram. That is where the videos will be posted. I do not routinely post any of the live math videos on Facebook anymore like I used to. So the vast majority is done on Instagram. So if you want to see more videos, please check out that. I already have about 800 up there for you to access. And I'm going to try to every now and again include some videos on here for those of you that may not have Facebook. So that's what we're going to do in the video. So that's just a little bit of information about that before we start the problem. Okay, so many of you have probably already started the semester by now, so I thought I'd create some more content. So we're going to evaluate this improper integral here. This is an improper integral from negative infinity to positive infinity. We got xe to the negative x squared dx. So first of all, an improper integral is basically an integral where either one or both of the limits of integration are infinite. Okay. Integral can also be considered improper if it has a discontinuous integrand. So what you have to do for improper integrals is you can't evaluate them the way you would some other definite integral by just subbing in some value. Like, let's say, for example, if there was, I don't know, let's say it was a 0 there, and let's say, I don't know, that was some 2 or something like that. You would just use second part of fundamental theorem of calculus and just, evaluate the definite integral. You can't do that for improper integrals, though, because infinity, or negative infinity in this case, are not finite values. So you can't just plug in infinity wherever you want to. You can't do it like that. So what you have to do for these improper integrals, and in this particular case, we're going to have to do something a little bit different, but what you want to do with these improper integrals is you want to basically create a limit problem, and you're basically going to take the limit of the result. So you're going to need to replace these infinite symbols or these infinities with some value, or B or C or T or whatever is being used. So that's the way you have to do it. So if I have something like this is basically going to be obviously an improper integral of an infinite interval. So if you have something like the integral from negative infinity to positive infinity, and you have f of x dx, the way you have to deal with these is you have to break them up. So the first part would be you would have to replace this infinity with a value, or this negative infinity with a value, and this infinity with a value. Pick a letter in this particular case. So we'll have negative infinity down here at the bottom, and then we got to replace this infinity here with some value. Let's say some value C is what you would replace it with. And then you would have your f of x dx. Now, because you have infinity, even though this one's negative, in both the limits, you can't just do one. So what you're going to have to do is you have to sum it up. So this would just be plus. And then this time, just take the C and replace the negative infinity, because you have to do it for both parts. And this part up here, which just end up, being your infinity, and then you'll have f of x dx. Okay. So that's what it is in a case like that. So that's what we need to do. So for us, we got from negative infinity to positive infinity. Sorry, that's terrible infinity there. And we got xe to the negative x squared dx. So what we can do is we can go ahead and replace that upper limit. This is an infinity, by the way. It's terribly written. Sorry about that. We can replace that with a 0. Okay, and we can leave the negative infinity down there. So this would be negative infinity. We have to replace that infinity with a 0. We need a finite value. You can't just plug in infinity. It's not a finite number. And then we have the same thing. We got xe to the negative x squared dx. Then we add that, and we do the same thing. So now we replace that with a 0, and this is infinity up here, and then we got the same thing again. Now we evaluate basically both of those improper integrals. So you have to break them up like that. So let's deal with the first one. So for the first one, we take the limit, okay? So we're going to replace, so we can write this as the limit. We can, I don't know, we can choose t. Some people use b. We can, choose t. As t approaches negative infinity in this case, okay? And we replace the negative infinity with the t. So this would be t now, and then, 0 is what's at top. And now we got xe to the negative x squared dx now. Okay? So now we can use the fundamental theorem of calculus and evaluate the integral now. So to evaluate something like this, u substitution is probably a good way to go. So if you pick u to be negative x squared, that means that du, which derivative of that, is negative 2x, using the power rule. So this gives you negative 1 over 2x du is equal to dx. All right, so now we'll have the negative 1/2 on the outside can be, or can be pulled outside as a constant. Then on the inside, we have e to the u du. We know the antiderivative for that. So obviously, this just gives you negative 1/2 e. We got to sub the u back in there, so that'll be negative x squared plus c. Technically, that would be how you evaluate that one. So now we need to take the limit as t goes to negative infinity. So this would be the limit as t goes to negative infinity. And I'm going to put brackets. And we'll have our negative 1/2 e to the negative x squared. And then we evaluate this from t to 0. Now, most improper integrals are not going to take that long, but since we had, and also in my videos, I'm going through every step meticulously. So I don't want you to assume that because it's taking me a long time to go through all of this, that it's going to take you this long. I'm doing a video, so I'm obviously explaining stuff to you. It will not generally take you this long, or hopefully it won't take you this long to go through and actually evaluate this. So now we can go ahead and use the fundamental theorem of calculus, okay? So you just, use the fundamental theorem of calculus. So it's going to be the limit as t goes to negative infinity. And what we'll have is negative 1/2. Okay. If we plug in the t, this would just be, so that'd be plus 1/2 e to the negative t squared. And then we take the limit as t goes to negative infinity for that. So this is going to be equal to negative 1/2 plus 0, which is negative 1/2. So for this first integral here, the one that we did here from negative infinity to 0, this xe to the negative x, this negative x squared. Sorry, I left that part off. We basically end up getting negative 1/2 when we take the limit as t goes to negative infinity. Now, the thing about these types of improper integrals is that in order for this improper integral to converge, both pieces have to, the limit has to exist for both pieces. So you can't have it where the limit doesn't exist for the first part, but then for the second one, the limit exists and says that the improper integral converges. It either converges with both of these, meaning you get out, the limit exists, or it diverges the whole thing. So you can't just have one, one that converges, one that diverges, and say it converges. Okay. So for the first one, we know it converges. Okay. Because we do, the limit does exist, negative 1/2, which is, negative 0.5. Okay. So we took care of that part. So hopefully you're good with the limit stuff. That's first semester calculus. So for the next one, it was from 0 to positive infinity, and then it was xe to the negative x squared dx. Okay. All right. So same thing here. You just replace your infinity with that. I call it a value. It's a variable. You plug the t in there. We use t. Most people use t. Some people, I've seen some, use b, or I don't think it really matters, but it's typically going to be t that you're going to be seeing. So this is going to be t approaches positive infinity this time. Same thing. So this is 0, replace the infinity with a t. This is xe to the negative x squared dx. Now we already know what the answer is because we basically calculated up here how to evaluate it. So we already know how to evaluate it. Now all we really do is take the limit. So this would be the limit as t goes to positive infinity this time. And we know what we're going to get. We're just going to get negative 1/2 e to the negative x squared. We know that because we just did it a minute ago. And then this time, it'll be from 0 to t, unlike from t to 0 for the first part of it. Okay, again, we know what we're going to get. It's going to be the limit as t goes to positive infinity this time. Using the fundamental theorem of calculus, we get negative 1/2 e to the negative t squared. If you plug in the 0, remember e to the 0 is 1, so that'd be e to the 0, which is 1, but if we multiply that by negative 1/2, we get negative 1/2. Two negatives make a positive, so this becomes plus 1/2. And then we take the limit as t goes to infinity, and this just gives me 1/2. So this part also converges because the limit exists. Okay? So hopefully that made sense so far. So we know that this improper integral is going to converge if the limit exists fully. Let me get another sheet. Let's get another sheet of paper here. Okay. So for the final answer, you have to write it a certain way. Otherwise, professors will get quite upset. Some are big sticklers on it. So what you have to do, notice here that when we use the formula for it with these infinities, you basically have to put your answer in kind of like that form. And some professors are real sticklers on that. They'll get upset if you don't write it that way. So this is what we had initially. And then it was xe to the negative x squared dx. So let's just use that formula that we used before to write the answer. So this would be 0, remember. Then it was xe to the negative x squared. What did we get? Dx. Okay. And remember, we added that to the integral from 0 to positive infinity. And it was the same thing in the integrand. It was xe to the negative x squared dx. What did we get? Well, when we did the first one, we got negative 1/2, and then we got 1/2 for the second part. So that means this would be negative 1/2, basically plus 1/2. And we know that that just gives us 0. So your final answer is 0. And the limit does exist, even though it's 0. Both pieces converge, as we know, so this improper integral converges. That's actually how you evaluate the integral, and then we could say the improper integral converges. And that's the answer. So these types of integrals you'll learn about in Calc 2. You don't spend too much time on them, but you can spend some significant time on them. So if you're in Calc 2, you'll probably see these briefly. So you got to break these up. You got to break them up into basically pieces. I doubt, I shouldn't say that because I don't know what professors are going to give, but they may make something like this a challenge problem. Maybe this one won't be as hard, but you just might get one that has negative infinity or infinity for one of the bounds, and that would be basically it. And they wouldn't give you one that you got to break up like that, but you have to take the limit. Okay, so go back to the first semester calc stuff with the limits at infinity. because that's what you would need technically for this part. Then you sum up both pieces and see what you get, and that's how you do it. All right, so that's it. See y'all next time.